Welcome to PowerFactory 2025. In this video, you can find out about the new features that have been developed for this version. We'll start with the user interface. PowerFactory now offers a dark mode, which is selected via the user settings. Colors in diagrams and plots are muted, as are the background colors used in the Data Manager and Network Model Manager. Let's now return to the default settings. As you may have already noticed, the arrangement of window groups and tabs is now more flexible. A combination of horizontal and vertical splits is possible. Another new feature is that the output window is by default collapsed to allow more vertical space. But there's an indication of unread messages which can be viewed at any time. And up and down arrows allow easy navigation through the messages. The user still has the option to pin the output window so that it's always visible. The drawing tools and project overview can also be collapsed. PowerFactory projects make use of external data files. In particular, many calculations generate results files. And external files can be used to hold data for parameter characteristics. In PowerFactory 2025, each project in a user's account has its own project directory. Within this, there's a folder for results files. And the project directory becomes the default place to store other files needed by the project, such as this characteristics file. Here, we can see the reference to this external file that's stored in the project directory. External files can also still be stored in other locations if required, as you can see here. With this new arrangement, it's now very easy to include all these external files when exporting the project by using the new PFDX export. This page allows the user to be selective about what's included if required. The new zipped format contains all the characteristics, making it easy to share projects with other users. A new feature for network diagrams is the introduction of filter layers. These can be based on inbuilt or custom criteria. Elements are automatically moved to the filter layers based on the defined criteria, and they can belong to more than one filter layer. As an example, in this diagram we have two filter layers set up to show the two voltage levels. We can then select the layers depending on which voltage we want to focus on. In the Reliability and Restoration Analysis module, a new Contingency Restoration Analysis function has been developed. This takes a user-supplied set of contingencies and determines a restoration sequence for each contingency. On this page, thermal and voltage constraints can be configured. There are various options for the restoration process. The main objective may be to restore supply to all customers, even if this results in some voltage or loading limit violations. But if this second option is selected, it means that the constraints will always be observed. We can see that in this example, 458 contingencies have been analyzed. The coloring of the diagram shows areas with successful restoration, areas where complete restoration is not possible, and areas where restoration is incomplete because of the need to observe limits. Reports can be used to view the results. The summary report gives an overview of the outcomes. For each contingency, a restoration report can be generated to show the sequence of switch events. A more general enhancement is the improved handling of meshed networks in reliability analysis. Previously, reliability analysis of distribution networks could only handle simple instances of network meshing, namely those where closed switches form single loops within an otherwise radial network. Now, network topologies containing interconnected or nested loops can also be analyzed. For example, these three feeders are separated by tie-open points. If the switches are closed, a nested mesh topology results, which would previously have prevented the reliability analysis from running. In PowerFactory 2025, the calculation easily handles such network topologies. In PowerFactory 2025, the short circuit calculation now has an option to be executed for selected contingency cases. This is useful, for example, if post-fault short-circuit infeeds need to be assessed for protection purposes or to ensure that remedial actions do not result in unacceptable short-circuit levels. The results are recorded in a results file and can be limited according to the change in short-circuit current for a contingency compared with that in the base case. Reports provide an overview of the results. For example, here we see for each short-circuit location the contingency that results in the largest percentage change in short-circuit infeed. It's then possible to select a particular case and calculate it directly so that results can be seen graphically or in a network model manager. For dynamic simulations, it's now possible to use the FMI interface version 3. The imported FMU interface version is automatically detected upon import. Likewise, version 3 of the FMI interface can be selected when exporting models. Dynamic modeling with Modelica has been extended, with the introduction of the hybrid modeling approach initially as a pilot version. This makes it possible to create complex nonlinear time-continuous and time-discrete systems either by using Modelica code or graphically with block diagrams. Enhancements to the unit commitment and dispatch optimization module include optimization of reactive power operating costs and extended options for redispatch costs for generators and HVDCs. In addition, shunts can be switched on and off with associated costs. In this simple example, the unit commitment and dispatch optimization is carried out for 1 day. The relative costs of the elements determine how they are used to manage the local voltage profile. Here we see the capacitor being switched on to provide voltage support. During this hour, when the voltage is too high, the HVDC link is dispatched, absorbing up to 40 megavars. Above this level, the cost would be too high, so it becomes more economic to supplement it with the megavar capability of the generator. The reports have, of course, been extended to cover the new functionality. Find out about all these and many other features in the What's New document linked in the video description field.